So I got this comment recently on one of my videos, and after talking to Creator Studio support, they tell you that you're not supposed to show people's icon and name. So unfortunately, I'm not supposed to do that due to privacy concerns. I know other YouTubers do it, but I can't afford to get in trouble on a smaller channel. So this is the comment that they wrote, and I'm going to address it in a response by video because I think the question they're asking is so important that all of you can benefit from their question's response as well. If I just responded to their comment, it's not going to be able to do it justice in a few paragraphs, and no one's going to see it. It's not going to benefit anyone else but them. So please read this entire comment and help, because I have never been able to find the answer to the phenomenon given below, despite going through every resource on the internet. Say I'm studying circles or permutations and combination or projectile motion from international Olympiads, and I've understood and memorized the theory formulas and solved some simple concept application questions. First, I would posit that you may not have actually understood, because understanding is not just you understand what they did. I would argue that understanding is knowing how to take that and use it in other ways, or to envision ways that it could come up either in competition or whatever field of math you're working in problems, in things like that. And I'm going to give some examples of that in this video, what I'm talking about. So there'll be multiple examples that demonstrating how to build mathematical intuition based on various stimulus that I'm going to show you either from an AOPS book, most likely from there, and then also from a brief lecture I'm going to give on a certain topic. And then I'm going to see if you can build the intuition on your own. And I'll show you what that looks like. Okay, so it says, then my teachers tell me to solve a torrent of medium hard questions by first attempting them on my own, and then if I'm not getting it, looking at the solution, and then over time I would be able to solve any new or old questions on my own. First, if you don't understand something, you don't understand some question from a book, and you have to look at the solution, that's fine. Sometimes we get to that point. We don't have infinite time, okay? Then you need to ask yourself, what was the part that I got stuck at? What was that part? What was the next step? What that next step is, that is your opportunity. You need to figure out how to get from where you were, step C, to step D. If you can't do that, make a note of it. I like small notebook. I like a notebook of some concepts that you think could benefit you in the future. If you just observe how somebody else did it, it's like watching a magic trick. Well, that's great, but you're not going to be able to do magic. So you need to understand how you can see those kinds of things. Okay? So also this method of first trying it on your own, and then if you're not getting it, this is the exact way that AOPS formats their books. I've got blur on, so it'll be hard to show this. If I can get it to show up here for my, there you go. Okay, so here's a problem. I call these gray box questions. It looks funny with my nose there, like I'm hiding behind the book. I call these gray box questions. And if you've ever done an AOPS book, the gray box question is like an example that you first do yourself. And then after you've done it, they tell you in the front how to use them. Then go and read the solution and see if you can learn a better way. This is exactly how you should be doing things. So they're giving you good advice here when they tell you to do this. Okay? But they ask, what exactly is happening here? It's not memory, since you will be asked a completely new question on the day of the exam. And even if the similar question is repeated, you haven't really memorized the question's solutions. You've only gone through them, or you've solved them, some of them on your own in the first attempt. Then what is happening here? What exactly is the biology science behind this phenomenon of going from understanding theory and memorizing it to actually mastering the art of solving hard questions? Now, I would say it's building intuition. When you learn, you need to learn with intention. You have to be asking questions. It is an active process. Information is not flowing one way. Information is absorbed, and then you take that and build on it. And again, I'm going to give you a chance to see if you can demonstrate that for yourself, or see what it would look like in a lecture type setting at the end of this video. So going on, and how can you go about this process consciously via deliberate practice? I'm going to show that in this video. My teachers also tell me that if I give up, I should read the question solutions introspectively and actively. Absolutely. What does that mean? Why does that work? Let's address all of that. We're going to start with an example that I want to give. And I think, again, I've given this example before in my videos, but it's just too powerful of an example, and we've got to go over it. This is from page 4 of volume 1. of the Volume 1 book from AOPS. And if you know me, I've told you before, I don't approve of pirating material. I understand some people maybe have less financial resources and perhaps you felt like it was necessary. I'm not going to judge you, right? I'm just saying what I think is best. And so you might be like, well, why do you have this PDF? I thought you said you should. Okay, here's the book right here, Volume 1. Okay, I bought the book, but I need to be able to teach it online. I can't hold the book up to the camera, and I don't want to buy a second copy to teach online because I don't want to, buy the book twice, basically. Although I probably should. It's been profound and very helpful. And maybe at some time I will, but at this point, I've got that book. I copied it onto here so that I could teach from it, and I use it in that way. Again, I just want to state for the record, if you do find yourself in a position where you have to use a PDF, all right, you did what you felt was appropriate for yourself. Try to give back later in some way. Purchase the book later. Make up for the fact that you used the PDF. Say you're in college now, you've got a job. Go back and buy that book and maybe give it as a gift to someone else. That way you're kind of doing two things. You're helping someone else learn. You're also supporting the people who honestly worked without income to write this book over probably several years' time to be able to refine it and things like that. So I just believe supporting the people who have supported your life. So here we go. Back to this problem here. This is bottom of page 4. Now the thing I want to point out is that a lot of times we go through these kinds of materials and look at example 1.8. For most of you who are, if you're doing math competitions, 1.8 is not exactly hard for you, most likely. Okay, maybe it's difficult for more of you, and you might have had more struggle than others. You look at this exercise 1.2 and you go, oh, I've seen all that. And your arrogance tells you, man, you already know this. You can just skip it. I see it in the forums all the time. Volume 1's not useful anymore. There's literally nothing. All the questions are harder than what that faces. Man, the hubris. That's just not a very good take. And we're going to show why in a couple different examples on recent tests of how Volume 1 has an impact, and why I say that if you're starting late especially, meaning let's say you're 8th grade or later, and you haven't done any learning at all, you should probably start with Volume 1, and unless you're going through it with a tutor who's experienced and can tell you, skip this, it's okay, or just do this for homework. This reading passage has a really important concept, they can point it out to you. This one, maybe, okay, I definitely know you already know that because they'll know you a little bit as well as your tutor. If you don't have that, I don't recommend skipping anything. And so let's see if I can, I don't have a writing thing on my pen right now. It says down here under this bomb symbol, they tell you the bomb symbol means, something to pay attention to. You may have realized that 5 is not the only number, which when squared equals 25. In fact, negative 5 squared equals 25 as well. So if you are asked for a square root of 25, what will you answer? In general, always give the positive root, right? But how many people don't even read this? How many people have gone through this book and never seen that writing because they're so smart, they don't need to read that? Right, I know, that's how we think sometimes. It's very easy to get carried away with our own ability, especially when we compare ourselves to local peers or things like that. We might think we're hot stuff and we don't need to read this kind of stuff. I would caution you to check the ego. I have to check mine all the time. In fact, I almost didn't start this channel because I thought people will see right through me and realize that I'm not that good or something and they won't respect me. But I just decided to own it. Like there's people better than me. It's okay. There's people better than you. And don't think so much of yourself that it's beneath you to read these little passages in a section of the book that you think you've already learned. And ask yourself with intention, well, how would this come up in a problem? Right? We should be asking these kinds of questions as we're reading, as we're learning. So they tell you a good rule of thumb is if the radical sign of the fractional power was in the problem to start with, then we are only looking for the positive root. If we force it to have a fractional exponent, then we must find all answers. So I'm going to give an example of this, the way I explain it when I teach it. The way I explain it is I say this. If you have x squared equals 9 versus x equals the square root of 9, why does people think, oh, it's square root of 9, it must be plus or minus 3, right? But it's not. When you see square root like this, if it was supposed to be negative, they would put a negative in front. So why does this one really get a square root? And the way that I explain this is the following. If you put square root here and here, a lot of times teachers who are a little bit, they're not mathematicians. They just teach this stuff because, You learn this in some grade level before you get to people who actually majored in math, and they maybe aren't as passionate about the underlying concepts, or they've forgotten why they're this way. They just tell you. It's easier just to say, oh, don't forget to put plus or minus when you square root. So you write plus or minus 3, and many people's brain says this is generating plus or minus. In fact, it's not. It's the other side generating it. The square root of x squared is, in fact, identical to absolute value of x. And so the way I usually explain it is what really happens is you take a pit stop at absolute value of x equals only positive 3. Then when you peel off the absolute value, that's when you get your plus or minus. Okay? So then the plus or minus comes from the absolute value, which we don't usually write, and most teachers just skip that middle kind of thinking and just go straight to this, which causes students to think that it's that plus or minus that's causing it. I wonder if I hit this arrow. No, I want new whiteboard. Okay, I'll need that later on. Okay, so that's how that works, and that's why you get plus or minus for that. So let's go on. They talk about it here. Here's the same example, x squared equals 9. They don't really show the absolute value aspect. That's just my way of explaining it, because those are the same exact graph. Okay, so having read that, after you've understood that, let's go forward and see a way this gets applied in some ways. Okay, here's another example here. Look at this example 614. 34 square root of 34 minus 24 root 2. I'll write it up here. Square root of 34 minus 24 root 2. And they want you to solve this. And we know that it's going to be, we guess it's probably something like this format. X plus y root 2 is what it comes out to be. And what we would like to do is square both sides to solve this. Right? If you've never seen one of these done, this book has several of these types and it helps you get better at them. So if you square both sides right now, you will get 34 minus 24 root 2 equals x squared plus 2y squared plus 2xy root 2. Okay, and so again, what did I just do there? This is the way a lot of the AOPS books explain it. They show it like this, where you go a plus b squared. They write it as a squared plus b squared plus 2ab. Instead of what I was more familiar with, putting the 2ab in between. So I've done their method here. Okay, so now, why would I write it this way? This matches this, and you go x squared plus 2y squared equals 34, right? And you get 2xy is going to equal negative 24, okay? So obviously one of them has to be negative, but not the other. But which one's which? We don't really know. So all we're doing is matching. The 2xy equals this negative 24 here, because it's got the root 2 attached. This is a theory. We don't know this is going to work, by the way. So now we just do some trial and error. I'm going to divide by 2. Xy is negative 12. Let's try, it could be like negative 4 and 3 or 4 and negative 3. Let's say that I make the x the negative 4 and the y the 3. So then what would that give me? 16 plus 2 times 9, 18. That is 34. This is going to work, but which one of these two is it? Is it negative 4 plus 3 root 2, or is it 4 minus 3 root 2? Because both of these, when you square them, both of them will give this inside expression of 34 minus 24 root 2. Let's go see what they tell you to do. And we're going to minimize this and go back and look at what they wrote in the book. Okay, so they come down here, you're doing this problem, right? And again, for many of you who are experienced, you've already seen stuff like this. So when you see this example 614, perhaps you go, I don't need to learn from that. I'm trying to go fast. I'm trying to learn so much. I got to complete all these books and go real quick because I don't have a lot of time and my time's important. And so what do we have to do then? Let's look. If you look down here at the bomb, again, the bomb is a warning, right? If you try to do 3 root 2 or 4 minus 3 root 2, right? Let's go back to my whiteboard here. 4 minus 3 root 2. Which of these is bigger? 4 or 3 root 2? The way you check is you square them both. If you square the 4, you get 16. If you square 3 root 2, you get 18. Since the 18 is bigger, the 3 root 2 is actually a bigger value. So then if 3 root 2 is bigger, and you were to do 4 minus 3 root 2, you're getting a negative value. Think about what that means. That's going to mean that the square root, right, the square root of something is equal to a negative. Is that okay or not okay? That is not okay. You can't take the square root and get a negative value. Maybe you could in some higher math, but not at the level that we're at. So in real numbers, no, it's not going to work, but probably there's some dimension of math in some way that they'll explore this in the future. Who knows? I don't know. I can't remember. It's been a long time. But I know it right now, all through high school math, this is not allowed, and yeah. So, or on the competitions. So you need it to be a positive number. That's the rule. Okay, so now how does this play a role? Well, this is just a simple concept, right? Maybe when you were doing this, you might have made a note. Hey, how could I make a note here? Let's go back. Let's click this arrow, open up a new one. What would my small notebook concept look like? As you know, I'm a big fan of small notebook. You put concepts in it where you learn something or there's a formula. You might write for your next concept, number 4, the square root of something squared must equal positive. So you might put here, verify that it's positive, right? Something like this. Put exclamation point, right? Put a star, something like that. Don't forget. You're reminding yourself. Maybe you made that mistake at one point. Now you're saying, hey, future self who's reading these notes, don't do this. Make sure it's positive. Okay, that is learning with intention. You're looking for places that you could conceivably make a mistake in the future, and you're heading those off at the pass. Let's get a look at what happens. Let's look at the 2021 February test, AMC 10B, everyone's favorite, problem number 2. Here we go. We've got the square root of 3 minus 2 root 3 squared. So many people were like, oh, look at me. I know how to square root a perfect square. And they don't realize it's not just what you see in the parenthesis. Because you're going to need to recognize, let's go back to the whiteboard, it's actually the absolute value of 3 minus 2 root 3. The people who really paid attention when they were going through this content didn't think themselves above it. Not so arrogant, oh, I have nothing to learn from that. I know all that stuff. You don't know, I always get straight A's in all my math classes. I don't have time to waste on that. Okay, stop being that person. Number 1, humble yourself before what you're learning. Always look, even if something's easy, find a way to gain some insight from it, right? Don't make yourself think of yourself in that way. It's not healthy. It's not going to help you learn in a better way. So this is really what this is. And if you know, the absolute value of a minus b is a piecewise function. It's a minus b only if a is greater than b, or equal to, we could say. But it's the reverse, b minus a, when a is less than b. Well, that means which one of these is bigger, 3 or 2 root 3? Let's put the box, square both sides. 1 is 9 and 1 is 12. The 2 root 3 is bigger. That means this is bigger. So when I have the square root of 3 minus 2 root 3 squared, that's equivalent to this. And because the right term is bigger than the left one, you reverse the order. And that's what so many students could not make themselves do. They thought it was a troll question. It was so unfair. No, it's a fundamental concept that you didn't take the time, not you personally, maybe it was you, but just people didn't take the time to drill into themselves. They thought it was beneath them. Let's go look at the statistics for this question. So, question number 2 right here. 60% of students got C. Let's go back and look at the problem. If you look at it, if you just thought you could just make it 3 minus 2 root 3 plus 3 plus 2 root 3, look at those 2 root 3's cancel. Oh yeah, right? They think they're so good and they get C and they're on to the next question. I'm going to get 80 qualified. Okay, too big for your britches? Slow down and think, right? They're going to be trying to get kids like that. That's what they want. I hope many of you, when you saw this, you learned from it. It's okay to be that person, unless you continuously be that person and you don't learn from it, okay? So what happens is you should have switched the order. You would have had 2 root 3 minus 3. When you added it to this, the 3's would have canceled and you would have got D 4 root 3. Statistics show 25% got that right. Right? You look at the next question, 63%, 80%, 87%. This is the MAA statistics, general reports by item difficulty if you want to look these up, okay? And so this was the one that most people got wrong early in the test. I mean, there's not another question with the lower right until you get to number 12, I think. Right? Or okay, so 7 also had a pretty low right one as well. Okay, but you get the idea. A lot of people, 3 out of every 5 people essentially, got tricked by that question. Why? Because they're not learning with intention. They don't pay attention to the writing here for the example. They got what they got. They don't need to read that. Maybe they didn't even do the problem. They didn't pay attention here when it said, warning, if it gives you a square root, find the positive root. That doesn't apply to me. I already know that. That's where you have to make your change, right there. That's the first example of one I want to demonstrate. Let's look at another one. I'm going to go to another question that was asked by another person. They're talking about AMC 12, 2021, I believe it was 12A, problem number 9. It says, at first glance, that problem number 9 could be solved via an alternate approach, such as, it seems that problem could be solved, such as brute force, working backwards, testing out choices or small sampling. Apparently no such safety net exists on this one, but you're not likely to make this realization until you've burned up several valuable minutes. Parenthesis, I don't know very many people who would look at 3 plus 2 and immediately say, hey, let's use 3 squared minus 2 squared instead. Look at the stats and on they go, 19% left it blank. Well, I wanted to address that as well, and so I responded to the person and I explained how that intuition might have formed. Let's look back at, again, volume 1. It's so useless that we're finding lots of use for it. Maybe it's not useless at all, and it's our opinion of it that's actually useless. So let's look here. I'm going to start with example 145. It says when x to the 9 minus x is factored as completely as possible into polynomials and monomials with integral coefficients, how many factors all of it are there from mu alpha theta 1992? Let's go ahead and go back to my whiteboard. We'll pull up a new one again, create new. All right, so it was x to the 9th minus x. A lot of people won't even bother doing this. Again, they feel it's beneath them. Do you? Maybe you shouldn't. These kinds of problems are worth doing. Let's get a look at what this looks like. Okay, so I factor out an x. I get x to the 8th minus 1. Okay, then that's difference of squares. So you get x times x to the 4th plus 1, and you could write x to the 4th minus 1. I advocate not to because you should recognize that's still difference of squares. And you get x squared plus 1, and you're going to again get x squared minus 1 attached to it. Right? But that's also difference of squares. So you get x plus 1 and finally x minus 1. Okay, you might have had this type of problem in your school. Honors class, Algebra 2, these kinds of problems get done. If you have a really high level honors class at a private school, maybe even Algebra 1 would have you do stuff like this. Okay, so you've seen this, great. All right, now let's go back and look at the next problem. Let's look at 148. Factor as completely as possible with real coefficients x to the 8th minus y to the 8th. Okay, this is the second example I'm giving of how to show how to build intuition from doing problems and then seeing where that intuition comes to fruition, where you get to implement it. Okay, it's not the same question, but it's similar. You recognize the similarity because you took notes on what you learned. Let's go look at it. So I'm not going to do this whole problem, in fact. I'm going to do only part of it. X to the 8th minus y to the 8th. If you were to factor this, it's x to the 4th plus y to the 4th times x to the 4th minus y to the 4th. Great. But then this is difference of squares. It's the same game. It's just that instead of 1, we have y. So you're going to have x to the 4th plus y to the 4th, and you're going to have x squared plus y squared instead of 1 squared, x plus y, and then x minus y. Oh, okay. Okay, look at it. Look at it carefully. X to the 4th plus y to the 4th, x plus y squared, x plus y, x minus y. Now, if you took time, I write these down as interesting factorizations. It's in one of my notebooks that I made, one for AMC 8. So, for instance, I will do, let's see if I can show you one here. I probably can't because the camera's on the blur thing. I can't show you. But I add interesting factorizations. I memorize this because it's kind of neat how it works like that. Let's go see how it plays out. Let's look at the question from, that's not the whole problem, by the way. It wanted you to do more than that. You can see the solution to it here. And they've got this same thing written that I've got. And they continue to go on to show what more you can do. And you can learn from that also. But let's go look at the question. It was 2021 AMC 12A problem 9. When I showed the solution to this problem, you can watch it on my rapid fire video, I pointed out that what you might do, how you could recognize what's going on here. First, look at the last 3 terms on the left. Do those look familiar? Well, they do if you swap them for x's and y's. So how could I then have used this? What if I took it and I said, okay, let's just make those x's and y's. What would it look like? It would look like x plus y, x squared plus y squared, x to the 4th plus y to the 4th. What is that? Is that the same as what we just wrote on this problem? Yes, but when we learned this, if we ever did this problem at all, then did we take note of this kind of thing? Are we observing it with intention and asking how it might come up on a future test? Maybe, maybe not. A lot of times we think some concepts are not worth taking note of, or we just forget. Don't be so quick to rush through problems, solve, that you're not analyzing how that problem could be used in the future. So if I took what was written as 2 plus 3, 2 squared plus 3 squared, 2 to the 4th plus 3 to the 4th, and I just think, what if I change the 2's and 3's to a variable just to see what it looks like? A lot of people, if they saw this, I bet would think, hey, what if I multiplied that by x minus y? You might not think of it when you're looking at the numbers, but you'd be surprised how your perspective might change when you change what you're looking at. And in general, on the test, always try to manipulate what you look at in some way. Make it look different. Maybe the different appearance, not just in your mind, put it on your paper. You might see this and go, oh, this reminds me of something that you kind of had forgotten. It's in the long-term memory somewhere, but maybe it's in your small notebook or something like that. And you go, I know what to do here. And then you apply it. And so if you go back to that problem, the trick was also to reverse the order. So make it 3 plus 2. And now if you multiply by 3 minus 2, that's going to give you 3 squared minus 2 squared. And you multiply that with 3 squared plus 2 squared and build all the way out, and the problem simply falls apart. But who has that intuition? It's people who went through volume 1 and they paid attention to the solution when it showed us these kinds of things. They looked and thought it was interesting. Why are they even powers? 4, 2, like that. Going up, just doubling the power each time. The next one is x to the 8th plus y to the 8th. Those people who observe that and think, maybe I could use this in the future. They're the ones that look at this and go, I've seen this before. I've seen this. And then they get it quicker. And that saves them time so that they can do better on problem 10 that I did. When I did problem 10, I lacked the intuition I needed for that problem. I still got it right, but man, was it painful. People who had the intuition on that saved time and advanced forward. So let's go to another example here. This example comes from chapter 3 of the same book. You've got example 312. Jim drives to his mother's house, which is 40 miles away, and then drives back. On the way there, he drives 40 miles an hour, but on the way back, he drives only 20. What is his average speed for the whole trip? Now, if you do this the normal way, you would go, it's 40 and 20, right? You do rate times time equals distance. This is a staple of every test. You have to know it. Everybody should know this. So he goes 40 and 20. The distance it gave was 40 miles away, and he was driving, yes, that's right, 40 and 20. And the distance here is 40, and then it's still 40 when he drives back, right? So you drive, you get the time would be 1 hour, the time here would be 2 hours. And then you will do total distance over total time, 80 over 3. And this is 26 and 2/3, great. But they want you to do that first so that you can see what comes next. What comes next is exercise 3.5. Do the same thing, show that it's true regardless of the distance to his mother's house. Now, if you're like me, when I first learned this, that's intriguing. Really? The distance doesn't matter? I would think that somehow it matters, but it doesn't. And those kinds of peculiar realities are especially things that you should be noting, right? So when I learned this again, you're going to go through, you demonstrate it to yourself, and how would you do so? You would do so by changing the 40 to a D. The D is D for distance, right? So then what do I get for the time? The time's no longer 1, it's D over 40. All I'm doing is time equals distance over rate. And then this one over here, you would get D over 20. It's still total distance over total time. Okay. Now, also, let's talk about how you can build memory here. If you solve this, you can, first of all, you can multiply by d immediately, and it becomes 2 over 1 over 40 plus 1 over 20. Do you know what this is called? It is the reciprocal of the average of the reciprocals. And that is the harmonic mean. And if you simplify it with numbers instead, like 1 over a plus 1 over b, and you multiply by ab on top and bottom, that will simplify to 2ab over b plus a. Now, b plus a being the rates, 40 and 20. Let's see what that looks like. If you know that the harmonic mean is applicable in this situation, right? Are you thinking about that? Right? They mention harmonic mean, I believe, in the book some point in there when they're explaining the solutions part. Are you thinking about its potential applications? Anytime you have equal distances, you can use harmonic mean. But wait, what if they upgraded the problem to 3 equal distances? Guess what? It still works. You can do 3 over 1 over rate 1 plus 1 over, it's still the reciprocal of the average of the reciprocals. And since there's 3 rates, there's 3 reciprocals. You divide by 3, which puts a 3 on top instead. If you understand how this problem worked, then if they throw a curveball at you by making it, he drove 3 segments of his journey, leg 1, leg 2, and leg 3. What was his average speed for the whole trip? No problem. You learned with intention. You thought about it. You didn't just do the work. Stop just solving the problem and getting the answer and thinking that you're done. That is the worst. You need to be asking questions when you're learning. How can I use this? How could I make a problem that utilizes this? Right? And so I'm going to give you more examples of that. So if you check really quickly, twice, I actually write this in my small notebook as twice the product over the sum. That way I don't have to memorize letters. I understand conceptually what it is. Okay? So twice the product over the sum is 2 times 40 times 20 over 40 plus 20 is 60. Knock off a 0. This is 2 times 3. Knock the 2 off. I've got 40 times 2 is 80 over 3. Same exact answer. And you can get it quick. But only if you learn ways to be faster and more efficient. Don't call it 2ab over b plus a. Then if I change the letters, you might get confused. Think of it as twice the product over the sum. Okay, now, let's go to another example of this. What does it look like? Here's another thing too. This is a somewhat, innocuous passage, right? You don't really notice it. It's between example 5, exercise 526 and example 5.9. There's this paragraph here. For others, we have to resort to trial and error. It's basically about prime factorization and how to go quickly. It says, dividing by each to see if it works. A tool to limit the amount of searching we have to do is to think about what the largest primes involved can be. Call the number we intend to factor n. Clearly there cannot be more than one factor greater than root n, since if there were more than one, their product would exceed n. It says, similarly, if n is not prime, there must be at least one factor less than or equal to root n. Now the important part. They're going to ask it for you, but you should be ashamed if you're not asking for yourself. Why do they have to ask us why? Why are you not asking yourself why? When you read things in a text, this is not pleasure reading. This is not Harry Potter, saves the day and whatever he did, right? It's not Lord of the Rings or something like that. You need to be engaged with what you're doing. You should be constantly asking why. Why does something work? Why? Before they tell you, see if you can generate the answer as to why. So let's look. Let's go back to the whiteboard. If I'm trying to tell if a number is prime, let's say I've got, 113, and I want to know if that's a prime number. Well, how many primes do I have to check? You don't need to check them all. You only need to check up to the largest prime, like 121 is 11 squared. So I would only need to check primes up until 11. And even then, that might not be that far even. Probably even up to 7 squared is probably all I need to check. There's no other primes between 7 and 11. Let's see why that is. Let's say we know that 2 doesn't go in. You know that 3 doesn't go in. You know that 5 doesn't go in. But let's look at what happened if we tried to do 2. This, right now, this is exploration. You are self-exploring. You're not being told what to think. You're thinking about it for yourself and drawing your own conclusions, building your own intuition. Don't have the information go one way. Take the information that you receive and build upon it. Let's see what this looks like. If it was 112, it would be 56. So this is 56.5. Okay? Notice that this number is large and this one's small. Now, if I go up to 3, 3 is going to go into 111 37 times. So that's going to go in 37 2/3. Okay, is that right? Yeah, that should be right. All right, now notice that the bigger number got smaller while the smaller number got larger. Right? This is, what do we call that? It's a constant product, which we're going to get to that in a moment. Constant product means they're inversely proportional. So as this number is going up, this number is going down. So if I do 7 now, I know 5 doesn't work, obviously. If I do 7, you're going to see, what does 7 go into? Does 7 go into this? No, it doesn't. Yeah, so 7's going to go into, I don't know, 70, and then you've got 7's going to go into 35, and that's 105, and then you've got, add 7 more, 7 goes into 112, so you've got 7 times 16. This would be 16 and 1/7. Okay, then what? As you go to 11, this number is going to dip below because 11 is going to go in 10 and 3/11. What does that mean by dip below? It's gone below the other number. Think about why this would mean we don't need to check any more numbers. Because if there was going to be an integer divisor of 113, down here, it would need to have an integer like a counterpart that also goes in. And if that integer counterpart existed, you would have had it on the left-hand list, right? You're going down to the numbers that you already checked up here on the right side. That's why you don't need to check anymore. Now, is this what the book says? No, they have a different way of explaining it. That's why you want to think about more than one way to understand something. It is an active, they said actively in that question, right? Go back to the person's thing. Introspectively, actively. Should read the question solutions introspectively, actively. That's what actively means. Be engaged with the solution. Don't just read it, right? If you're just reading, you're not absorbing, you're not really making it your own, okay? That's the key thing. Let's look at two more things actually. The first one is there's a video where I talk about this, the importance of don't memorize, understand. I show on the 2008 10B problem 17 how to do binomial probability. I then do another problem and show how binomial probability can be upgraded, adapted to a situation that's not actually binomial probability. But because we really understood why binomial probability works, we're able to do the second question so easy. Now, do you have to use that technique? No, you don't have to. There's other ways to do it and think about it. But for me, when I solved it, it made the problem a joke. And so that's what I show in this video. I will link this video in this description. One last thing. Let's see. Have you learned how to do intuition? I'm going to give another example. Let's make this large screen. When I teach direct variation and inverse variation, this is the way that I teach it. So in my classes, if you're interested in my classes, you can send me an email. I go through all of these texts and I try to enhance what they're teaching you. So direct variation versus inverse. Okay, so when they get to this, and I think chapter 4, the way that I explain it is the following. Sorry, I'm writing at an odd angle, like with my pen straight towards the board, so it makes it really awkward to write nicely. I write a lot nicer during my sessions because this folds into tablet mode, but I want the camera to be pointing it here, not like where it's normally located is at the bottom of my screen. Anyhow, so y equals kx and y equals k over x. Now, what are these things? Now, I'm going to explain it differently than the book does. This is my way of making sense of this. First off, memorizing the formula? How about we memorize how to know which one's which? I call these formulas level 1 understanding. Level 1 understanding is basically what they taught you. And I memorize it as the following. They're not going to mention the constant of proportionality k. Again, what you're doing right now, you're paying attention. See if you can pick up on other things that you could do here. I'm going to erase this k a little bit and that x. Let's go back and draw again. I want to write it nicer. kx. Okay. K is the constant of variation or proportionality. It's called both. Okay? You will see statements like y varies directly as x, or y varies proportionally with x, y is directly proportional with x, those kinds of things. And so all of those things basically mean write this equation. Okay? Now, what I do to memorize this is I say that the x, I try to think about ways I can memorize what is happening. in direct variation, direct, the x is directly next to the k. That's my mnemonic device for that equation. Over here, I say the x is inverted with the k. Nobody has taught me these things. Nobody. Okay? This is what I made this up myself. Now, technically inverted is more than just below. It actually is kind of like this. Like this is like inverted. Okay? But we can think of it that way because the x, if you flipped it over the k down below, it would actually look very similar to that. So I memorize it like this because inverted sounds like inverse. So if something says the height is inversely proportional with the width, then I can immediately write h equals k over w. Okay? Now, there is a second level to understanding. And this is one where you solve for the constant, which is never mentioned, typically, in these kinds of problems, by making it isolated. Don't mistake a variable or an unknown, a letter, as always being a variable. Just because k is an unknown doesn't make it a variable. It's a constant that we don't know. We call it an unknown. So over here, you can see that if I solve for the constant, what does that mean? What does it mean about y over x? Since it's equal to k and k is constant, this is the upgrade that you need to be able to do. You need to make it more easy for you to understand. I memorize it has a constant, what do we call the result of that? Quotient, constant quotient, okay? Over here, if you solve for k, level 2 understanding, if you can't do level 1, don't do level 2, because sometimes you need to be able to do level 1 for certain problems. But other times, this can be faster to do the level 2. I call it level 2. Nobody else does. It's just my words for it. Okay? So this over here is that there is a constant product. Constant product. Now, there is something I have not said. This is where the test begins. When you look at these two types of variation, is there anything that kind of reminds you of something else that you've learned? Anything, right? Think about that. Pause the video and ask yourself, look at these equations and think, does it remind you of anything else you've seen? Because the main goal is that math is not these separate little dots of information. It's this interconnected web. And by having your web connected with more than one thread, the memories become stronger, the intuition becomes stronger. So when people learn this, some books will point out this kind of stuff, but not all. Okay? I don't want you to start with level 2 understanding because it looks a lot like this, and if you don't really understand that k is a constant just because it's an unknown, you might get these two confused. And if I change the letters, k is not k, and I call it something else, or y and x are different values, and so on, again, it could be confusing to know which is which. For instance, let's say I write height equals length over, length over width, something like that. Well, which one is it? Is it level 2 of direct or is it level 1 of inverse? It depends. Which one is a constant? If L is a constant, okay, if L is a constant, then it's the inverse variation. But if H is the constant, say it's not L that's the constant, but H is the constant, now you have a constant quotient, L and W variables, and that means it's the second version of direct variation. Okay? Now, if you've paused the video and you're coming back, what I want to explain to you is what else you can get from this. Let's say we look right here. If you don't look at that and you don't think y equals mx plus b, now think like a test maker. What could I do? What kinds of questions could I make that rely on you to connect that direct variation is very similar to a line, a linear function? In fact, it is. What would the graph of direct variation look like? Let's make one more new screen. Okay? What would the graph look like if you compare y equals kx with y equals mx plus b? Let's say this book, for example, volume 1 doesn't talk about this. But do you? Do you ask yourself these questions, or you just solve a problem and you're done and move on? That is not learning actively. Okay? That's not learning with intention. Let's look. This implies that my b value is 0, but something else, it implies that m is equal to k. Okay? In other words, k is the slope. So if I say Chad looks at 5 graphs that he knows his friend Sean made of direct variation. Okay, there's some graphs, right? You got 5 graphs. You got like a parabola, you got this line, you got that line, you got a horizontal, and finally you've got this line right here. What is the constant, which one, after identifying his graph, he was able to tell what the constant of variation was. What is the constant of variation? A, B, blah, 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 blah. If you haven't connected these dots, good luck. What I wrote down in my small notebook, any line through the origin is representative of direct variation, and the slope is the constant of proportionality. Right? Does the book tell me that? No, it doesn't tell me that. I built on what they told me. I asked myself what it has to mean. It has to mean that k represents the slope of y equals mx plus b. It has to mean if I graphed it, because b is 0, it must go through the origin. So if you're looking for the graph of direct variation, it is a linear function through the origin with the slope being the constant of proportionality every time. That is what you need to do. That is building intuition. Okay? And then slowly as you go through the old tests and these books, volume 1 and other books, start to build up this knowledge. Start to gain insight. I hope this helps you guys. I hope this answers the question that the original commenter asked. If you can let me know what you thought of this, if you like this kind of thing, of what it looks like to build intuition, let me know. I'll make more videos like this if you guys like them. For now, I hope you guys had a Merry Christmas, and I hope you have a Happy New Year, and we will see you in the New Year most likely.